Okay, so welcome again to integrating OAuth and OpenID Connect session. Before I actually start with the topic itself, I'll start with some parallel. Many of you have mobile phones, smart mobile phones, or tablets. When you install a new application, you could very often see that the application you are installing is asking you to provide access to the resources like locality, disk space, calendar, and so on. So with OAuth, we will be doing something very similar, but instead of doing it just once, we may do it every time. Application needs to talk to another application. What actually OAuth is? OAuth is an open standard which is trying to define the standard flow of trust between different players. On one side, you have an application, a resource server, which is storing your data, your private data, which is protected by the application. On the other side, you have another device, maybe a mobile application, maybe a web application, and you run this application, and your mobile application wants to retrieve the data from your protected server. So how you do it? You have either an option that for each application, like this, you store your username and password, and you provide these two information to retrieve the data directly from a server. If you have many applications, that could be quite difficult to remember all the passwords. And also, you don't want to store your password here because this is a small device, it can break, it can be lost, it can be stolen from you. So you invite someone else. You invite a man in the middle, an authorization server. So you delegate actually the trust or the authorization from yourself to someone else. And that gives you an advantage of not need to remember many passwords or not so many passwords, because you have someone who remembers these things for you. When we're talking about OAuth, we are mostly talking about applications that use HTTP protocol to communicate. So on this slide, you can see the individual roles which OAuth specification is mentioning. We have a user, that's usually typically the physical person who owns and runs the client application. We have a client, that's the application that is asking for the data. There might be different kinds of applications like native application, a web application, and some others. We have authorization server. That's actually the man in the middle, the one who provides the authorization, the access rights. It grants the access to the protected resources, to protected data. And it also provides it with specific scope, with a specific extent. So you are not allowed to run any code you would like to, but only very specific action on the protected server, We have resource server. That's another role in the OAuth specification. The resource server is actually another application where you store your data, which is taking care of your data. And we have a resource owner that's typically the same person which is running the client application. So it's you, it's your data. You are giving access to a client application, this one. In OAuth, we're talking about four different types of grant. The most common used one is the authorization code. You grant the access through authorization code. This is used in cases where your user interaction is required, and it's done through HTTP redirection. There are implicit grants as well, which are simplified version of the authorization code grant. And the access token is not issued through communication with you through consent form, but it's issued directly. And then we have resource owner grant. It means that you provide your credentials directly, and the credentials are actually those that are used to protect your data on a protected resource server. And the last one, the last type of grant, is client credentials grant. So the application might be connecting on its own behalf. So it's not you as a physical person, but the application itself might be asking for the data. By the way, when we're talking about OAuth, the shortcut is Open Authorization Framework. It's not Open Authentication Framework. It's two different things. I think it was 3 years ago, there was an academy here on Global Summit where we were showing a very initial and very simple implementation of OAuth workflow between applications. And the academy was pretty simple. It was always manually coded. If you wanted to use OAuth, you had to do your own code. Since then, we have implemented the framework into the core system, into Cache and all our other products. So they will be available with one of the following releases of Cache. At this moment, if I remember correctly, it's planned for 2016.3. So how did we implement the OAuth? We have a couple, well, we have a set of classes which altogether make a framework. And these classes are separated in 3 different groups. We have a %OAuth. If you look at the class dictionary, you will find a package %OAuth 2. This is the package which is providing API for customizing consent page. And I will show you later the consent page when I do the live presentation, the live demo. Then there is a OAuth package, which is private to %sys namespace, so it's not accessible from anywhere else. And this one, in this package, we are storing access tokens. So they are not available directly, but there is another set of classes which can manipulate the access tokens. And you need access tokens every time you request the data from your client application to a server application, be it Cache-based application or Google or any other system. So the last package which we have implemented is %sys.OAuth 2, and here we have all the APIs necessary to manipulate the requests and the tokens. So let me now switch to a live demo. I have prepared a little web application where I will demonstrate how you can use the OAuth. But before I go to the application itself, I'm pretty sure that you are familiar with Stack Overflow. Every time you're searching for an issue with software, I use it very often too, so I'll go to Stack Overflow. And as you can see here, Stack Overflow gives you multiple options how to authenticate yourself against their server. You can either create an account directly with Stack Overflow, but if you already have, for instance, Google or Facebook account, you can use these accounts as a delegated account, as a delegated authentication. So you don't have to create yet another credentials. You simply use one of those which you probably already have. So this is actually what is OAuth about. It's about delegating authentication and authorization to someone else. And now, this is the simple page, or simple web application, which I have put together to demonstrate how OAuth works. I have a little cartoon, a little animation, which actually shows the message flow between individual actors with OAuth. So let me start it. So this image describes either the roles. So we have a client application, we have a user who's using the client application, we have a resource server on the right side which stores some data. And we have this authorization server in between. And before you can actually start using OAuth framework, you have to do some preparation. You have to register both your client and server, this protected resource server, with the authorization server. So the authorization server knows who these two applications are, and by this, it establishes a trust between these two applications, between the client and the server. So our authorization server issues client ID to both client application and to the resource server. And it also issues some secret, like a token, which is only known to either the client or authorization server, or a protected resource server and authorization server. But this information is never flowing directly between the client application and the resource server. So when I run a client application and I want to ask some data from the server, if I'm using authorization code grant type, I am first requesting client ID token from authorization server. And this is done through redirection. In my application, somewhere on the page, I have to put a little button which redirects me to authorization server. And I have to supply some JSON formatted object, which is defined by the OAuth specification. So when I request the client token from authorization server, it is redirecting me to consent page, and it's saying, is it okay for the client application that you give it access to the protected resources, to your data at protected server? And you can either accept or deny this request. If you say, yes, I accept it, then authorization server issues an access token, and then, again through the redirection, it's passing this access token together with HTTP request to the resource server for the data. And it's responsibility of the resource server, of the application which runs on the resource server, always to check for the validity of the token. If you don't check, anybody else can free access the data and retrieve it. So it's really a must. And you should be careful in implementing properly the check for the access token and for its validity. And we have this framework already in Cache, so you just need to use proper API. But once we have this access token, we can request for the data safely, and the resource server, when it validates the token, sends the data back to requesting application, and eventually invalidates the access token. So no one else can ask for the data using that access token. OAuth is becoming more and more popular. Many organizations like Amazon, Facebook, Stack Overflow, and others are using it more and more. If you would wonder what it would be a typical scenario, it's not only social networks, actually, where you would meet OAuth. You will find it in healthcare industry. The FHIR specification, which is latest development in IHE profiles, is using OAuth to authenticate the individual players. And also, you can imagine using OAuth, for instance, not only for patient portal, but for your internet banking. You may find this as one of possible scenarios. I have prepared two simple examples of showing how Cache can help you through OAuth to retrieve the data either from external systems, in my case it's a Google Drive, or from data which is living in Cache as a resource server and protected by Cache-based authorization server. So we not only are a client to another authorization server, we can be authorization server on our own. I apologize for not having big enough fantasy to call the demos other than demo 1 and demo 2. They probably should be called Google as the first one and Cache as the second one. That might be confusing. So let me start with the demo. First of all communication must be secure. So you should use HTTPS, HTTP over SSL transport protocol. So I'll just have to agree and proceed to my application. And I'll try to make it bigger so you can read it. Can you read it in the back row? Yeah? Okay, good. So this is actually a 2-page application, nothing else. This application, I want to retrieve information about my Google Calendar and my Google Drive. But before I go there, I have mentioned already that we have to establish a trust between the client and authorization server. So I will show you how we do it. In management portal of the new Cache versions, you will find a new item in the portal, in the security part. It's OAuth 2. And we have 2 sub-items, client configurations and server configuration. For the first case, I only need client configurations. Let me try to make this one bigger. So what you can see here is I have actually 2 servers, but one of them is the Google. That's the top one, accounts.google.com. And with Google, I have 1 client configuration. So let me have a look first at the Google. That's the authorization server. I need to provide details of where and who the authorization server is. And I have to provide some information about various endpoints. Don't forget, this is all about REST. So we're talking about URL endpoints. We have issue endpoint. That's actually where I have to redirect my requests and where the consent page of Google is living and served from. And then there are some other endpoints available, functionality available from Google, like authorization endpoint, token endpoint, user info, revocation endpoint, and so on. All these can be found at Google pages, so you have to search for the endpoints on the Google. But once you find them, you simply put them here into the configuration, and then you need to provide your client. So my application here, this one, is a client of a Google. So if you go to details, I will see what we put. You can name your application anything you like. Then you have to provide a client type. We support 3 client types: confidential, public, resource server. If you wonder what the difference is, typically a web application is a confidential client because your web application only runs on the web server. And the information about the secret token and client ID is living only on the web server. It never is passed to the client browser. So that's why it's confidential, because only web server administrator has access to that information. It's confidential information between you and the authorization server. There are applications like native applications that run entirely in the mobile device, which can't be confidential. You don't want to store your private information there, so you make these applications as a public, and you say that's client type as a public. And we have another one, that's the resource server, and you will see the resource server in my other demo when we'll be using Cache as authorization server. You have to provide also the SSL configuration to establish properly SSL channel over HTTP, and you need to tell the authorization server to which page it should redirect you after you consent with the consent screen, after you say, yes, I want to allow the access to the client application. Then there is some other parameters which you use to compose the host name, prefix, and port. So these actually build up a CSP application name. And here you can see client ID and the client secret. These two strings are generated by Google Authorization Server for me. I will show you later. I can't do it right now because of caching, so I don't want to break caching. But this was something that Google gave me when I registered on Google API's page, my application. So I simply have to take this information and put it here. And as we, in this first example, we are not using OpenID Connect. We don't need to provide Java Web Token and all these cryptographic details. By the way, I mentioned a new term, OpenID. OAuth is about authorization. It has nothing to do with authentication. So with OAuth, if someone is clever enough and arbitrarily makes the same string that you may interpret as a valid access token, that could happen in theory if you are lucky and if you have big computing power. So there is nothing to stop someone from making a false access token and access the data on your application and pretend that it's you. So that's why there is formally independent initiative called OpenID. This one was actually dealing with making sure that the person really is who he claims to be. And in recent version, OpenID Connect, the OpenID is using infrastructure of OAuth framework. Originally, these two things had nothing in common. But recently, the recent incarnation of OpenID Connect is using framework of OAuth. So you can think of it as a OAuth on steroids. And so with OAuth, you can now guarantee that the person really is the one who is saying that he is. And this is because of using cryptography. So let me now go back to the example. So I have my first screen, and I want to ask Google to authorize my request to retrieve the data from a server. So now I'm redirected to Google consent page, to Google login screen. So I have to sign in with my Google account. And as you can see, I'm really on Google's website. And Google is asking me, you know, this application cache demo would like to have offline access to the resources. You can either deny or allow. So I allow this access. And now I'm redirected by the instructions in the Google registry and in cache client register to resulting page. This page actually lives on the authorization server, in the resource server. In my case, I put everything into one cache instance. And the data, however, is taken from Google. This data get user info API and data from Drive v3 files. These are the APIs provided by Google, and information is coming from Google because I have authorized myself through the Google account to retrieve this information from Google. So what you can see here, this is just debugging information. It gives me the user information. That's information Google has stored about myself, about the account I used to log in. And it tells me what files there are on the Google. So now I can go to Google. And I go to Apps, Google Drive. You will see there's two files available. Okay. So there's a document called Getting Started and hidethere.txt. If you go back to this cryptic page, you will see there's application, this is this Getting Started PDF file, and there's hidethere.txt. So these are the two files. And similar for Google Calendar. If I go to calendar somewhere. Here. A little low. So when it's loaded, we will see the list of calendars I have available with Google. One of them is called Holidays in Czech Republic. If you look here back, somewhere here, there is a Holidays in Czech Republic. So this is the information coming back from Google's resource server. So how did I put this information together? How does the client application looks like to retrieve this information from Google? So I go now to Atelier. And here's the actual code. There's some decoration, which is not important, but here we go. Remember, we are using OAuth, so we always need to check whether the request is coming with authorization already. Is the request coming to this application authorized? If it's authorized, we can retrieve the token, and we rather revoke the token and request a new one. That's a security precaution. And then, through the API, presents this OAuth 2 package, an authorization class, we establish communication. We retrieve the URL from our registry, from the configuration, and also we provide what scope, what functions we want to run on the protected server. In our case, we are asking for user info profile and for drive data, metadata read-only. That's the list of the files from Google, and calendar, again, it's read-only. I can pass some other parameters, like enforcing the consent form for every time, or I want to include granted scopes. So you can see how you can pass some additional parameters to the function call. And the result of the function call is URL. This URL contains the client ID token, which is then sent to consent screen. So once we apply or we agree with the consent, we are redirected back by the Google to this page. And again, we have to make sure that this page can't be called without being authorized at the beginning. And we can retrieve the actual data. But before we can retrieve the actual data from Google, we need to provide this access token we were given. And in order to construct a proper HTTP request, we're using standard classes, %net.http request, but then we have to add access token to the HTTP request through our OAuth framework classes. Once we do this, we can safely call, just too quick. We can safely call the API functions from the protected resource server. So in my case, it's just a little function here. And as you can see, I just add the access token to HTTP request, read the data, and I'll just show it in very raw form. Now, I just try to get the data. This application is not about showing you how you can convert this JSON object to something more colorful, tables or so. It's just plain data retrieval. You might be wondering, there's one thing I want to mention. You might be wondering, where did we register ourselves with the Google? So if we go to one of the pages, and we'll look at our account, there should be somewhere APIs. is so many pages on Google, it's not easy to remember which one it should be, but I think that will be the correct one. So every authorization server can have it implemented in different way. We go to credentials. So these credentials are actually defined by the Google, and this information, the client ID, client secret, and authorized redirect URIs, this is the information you have to provide to Google. So Google provides for you the client ID and client secret, but you need to provide the redirection page so Google knows where to redirect you after you submit either apply or deny, if you submit the apply function. So this is where you are redirected in your application. So let me now go to second demo. The second demo is very similar to the first one. It's also just 2 pages application. In real life, it's much more complex demo because in real life, it should actually live in multiple servers. For simplicity, I just put everything into one server, but you should have a client server which runs the client application. It might be cache, it might be anything else. In my case, it's cache. Then we have cache-based authorization server, the server which registers these applications that can use ourselves as a delegator of authorization and identity, because we also act as OpenID Connect provider. And last, you have another cache or another application. It could be anything, not necessarily just cache, but in my case, again, it's just cache. So I have in theory, 3 instances of cache, but they are all in one cache for simplicity reason here. So it might be confusing maybe for you, but I was just too lazy to set up 3 different cache servers and deal with certificates. So I just put everything into one cache server. But let me show you how it works. You see that the first page is very similar to previous demo. We also have this little button here, authorize for ISC. But before I go to that authorize, I again switch back to portal, because we have some more configuration to do with the portal before we can use cache as an authorization and authentication server. So in cache, we start with server configuration. If we act as authentication or authorization server, we have to create this new configuration, this new entry. So we supply an issuer endpoint, which is actually somehow created from the information given here, from the host name, port, and prefix. So this is all automatically configured. And then we tell what types of grants we support. In our case, we support all these 4 types of grants, which I mentioned earlier. And we specify what scopes we provide. You can think of scopes pretty much the same way as roles in cache. It just tells what you're entitled to run, what functionality you can run. We have some section here where you can provide your own classes to provide customized consent form. I'm using the standard one, so I'm not touching these default values. You can also specify within the portal who actually, the user in cache, what privileges, what roles he or she has to have in order to be able to maintain this customization. And then we again have to provide the SSL configuration because it's all secured connection. And here, as we also act as OpenID provider, which is somewhat specified here, we need to tell what signing algorithm and encryption algorithm and key algorithms do we provide. This is all X509 cryptography. And this is used by OpenID Connect. And also, we have to provide certificate. Actually the configuration for the certificate, so credentials, which are storing the certificate. There's two certificates involved. It's ours as an authorization server. There is theirs as a resource server. So this is the server side. And similar to what we did for Google, we need to register the two clients, the client application and the server application, because they are all running on cache. So I just have to do it from here. So the client application, in this case, is just asking for authorization code, grant type, and you provide the client ID allocated by the server to you. It's actually generated for you. You have to provide redirect URLs, same way as we did for Google. And you have to provide launch URL and authorization display. So this is the place where you can configure your consent screen. And you have to supply your credentials, your X509 credentials. Same with the other side, with the resource server. So in case resource server is cache application, you should register yourself against the authorization server. So here we go. We are registering ourselves as a resource server. That's our client type. And we are given client ID and client secret. And that's it. For the resource server, the configuration is simpler. And again, we have to provide our credentials that protect the X509 certificate. So once we have done all these settings, we can continue with the example. So I will now navigate to consent screen, actually to login screen. I have to log in first to authorization server. In this case, it's ours cache, so I'm using my own account with the cache instance. Now I am successfully logged in. The consent form comes, and it's saying demo client, wherever I call this application, is requesting these permissions: OpenID Connect, user default profile information, first scope, second scope. This is very important. OpenID Connect. That means that not only authorization token or access token is issued, but also we issue a user ID token where the information about user signed by the cryptography and encrypted is sent back to the client application. So in order for this to work, there should be certificates on both sides, and that makes it secure. So you can really trust that the information about the user is really the user who is connected to the server and who is accepting the consent. And very similar to what we saw already in the first example, we now retrieve the information from, in our case, cache application, which is acting as a resource server. So there's some debugging code, like showing you whether we have valid Java web token. We do some introspection to show you the data. What is interesting here is user information. So this, if you are familiar with cache security, there is always a user who installed the system. In this case, it's me because I use that name. And from now on, you can do whatever you want with the server application. So now you are inside cache as a protected resource application. So first of all, you have to check for the validity of access token, and then you can provide the data. And you have two options now because we're using OpenID Connect. We have the true account information coming with the request. So now you are in cache, and the question is, what should I do? By default, this code is run as an unauthenticated user. So the question is, does the unauthenticated user have enough privileges to run the code to retrieve the data? If you do some more complex configuration or security, you may have situations where unauthenticated users are actually allowed to do nothing. There's no privileges at all. So you have to give either temporarily you have to escalate the privileges for that particular process for the unauthenticated user, or alternatively, you can use other mechanisms like delegated authentication. But it depends what is better scenario for you. If you run internet banking or maybe patient portal, you have hundreds of thousands of patients connecting to your cache database, you don't want to store hundreds of thousands of external accounts. So in this case, you simply use the role escalation through privilege routing. You may have another scenario where you would want to have the account information stored internally with cache, where there's some limited amount of these external users. So then you can consider delegated authentication. So it's up to you. In my example, I was actually setting up a very simple delegated authentication. So I assigned the role which was coming from the scope to the user, and I created a user in the application. But that's, I would say that's an exception case. You rather use the other one, which I mentioned, just escalate the roles through privilege routine. So let me just switch back to Atelier. You will see that the first page is very similar. In fact, it's the same as the previous demo. We only supply slightly different scope string. We now provide OpenID profile, and that's the fixed string. If you want to use OpenID Connect, you have always to pass OpenID profile string. And then it's up to you what scopes you pass as the rest. So I'm just passing scope 1, scope 2. And on the server, on the resource server page, first thing you have to do, check access token. If it's not valid, stop. You should not continue at all in this particular application. If it's valid, if it's authorized, you can continue. So we do this little debugging, just showing what we've got, what information we've got from the authorization server. And we can eventually run arbitrary code to send the data to client application. So you have two options described here, which I already mentioned. Either use this privilege routine to escalate the privileges, or use some other mechanism. So that's the code. As you saw, it's just 2 pages. It's very simple to use, and there's only maybe 5 classes you really need to work, and a couple of methods if you want to use OAuth. There's one more thing I want to mention. This application, this web application, will be available through community portal later, and you will be able to download it. You will be able to go through the source code. What I also did for you, I've put a tutorial as a web page, and it's in detail describing what the OAuth is, very briefly, the OAuth, but then all the setup. What to do, the step 1, step 2 for the demo 1, demo 2, what prerequisites you need, how to set up these configurations. So if you set it up correctly, then it will directly point you to proper part of management portal. So you can play with this. You will have the source code. The only thing is that you have to wait for some future version, 16.3 as I said. And the last thing, before we finish, as time is approaching, I would like you to point your attention to our community portal. So please feel free to use community portal to post your comments, your questions, search for answers, and also please do not forget to fill the survey form, the survey application. And if you have questions, ask me now. Well, I think so, yeah. It's not far from now. In fact, the code is in 16.2 because of fire, but it's not documented at all. There will be much better documentation in 16.3. So it is. Yeah. I was actually running on 16.2. This is running 16.2, but there's no documentation, so you have to either find the documentation through the portal, or just ask me or product managers. Andreas Dikov or Marvin Tanner. Marvin Tanner is the developer who wrote the internals specification. And I think that's it for the session. If you have no more questions, then thank you very much for attending and have a safe flight home. And goodbye.